My name is Alan Correia, and I am currently in my final year of an associate degree in mechanical engineering. I study part-time by distance education through Central Queensland University. My presentation will be about using phased array ultrasonic testing to accurate subsurface discontinuities in structural fillet welds. My engineering associate project focuses on the capabilities of phased array inspections being carried out on partial penetration T-fillet welds, specifically those which are welded with a submerged arc welding process. The sub-arc method is basically an automated welding technique which uses a granular flux to shield the arc during fusion. NDT stands for non-destructive testing. It is a term that encompasses various inspection techniques that are used to determine the presence of defects in components or welds. MT stands for magnetic particle testing. It is the most common technique when inspecting welds in carbon steel and looking for surface breaking discontinuities. UT refers to ultrasonic testing. It is often used to detect subsurface discontinuities in components. PAUT is phased array ultrasonic testing. It uses the same principles as ultrasonics with the added benefits of beam steering, focusing, and providing a permanent record of results. It is quickly becoming commonplace in NDT laboratories and workshops. Today, I will discuss how the principles of phased array ultrasonics can be adapted to create an effective inspection scope when searching for subsurface discontinuities in T-fillet welds. Linear scans are essentially various ultrasonic waves that leave the phased array transducer at multiple exit points, but all exhibit the same angle of refraction when entering the component. Sectorial scans differ by having a single exit point, but each sound wave propagates at different refracted angles in the part. PAUT measures and records all data in side view, end view, top view, and amplitude, which is color-coded to detail intensity. Phased array transducers differ to conventional ultrasonic ones by having multiple crystal elements, which are all individually wired. This allows excitation of each element to occur independently, or in phase, which produces some unique capabilities. Timing of excitations can be programmed so that this sound energy interacts to converge or focus at a predetermined depth. Delayed firing order can be utilized for beam steering and focusing to optimize inspections. The advantages of phased array ultrasonics are as follows. Permanent record. All scans and results are saved digitally and are able to be viewed, analyzed, and stored for future reference. Using a known datum point, you can determine accurate locations of defects. Multiple scans using a single transducer. The ability to take a transducer means scanning speeds are essentially sped up. There is less equipment required to conduct inspections and effectively creating a relatively simple data acquisition process. Linear and sectorial scans. Both linear and sectorial type scans can be done at the same time. In one single scan, multiple focal laws can be collecting data independently, which results in a more comprehensive and thorough scan. Software capabilities. Collecting A scan, B scan, C-scan, and S-scan data gives greater ability to determine the discontinuity type. Most systems also have the capacity for data to be manipulated post-scan to increase accuracy in results. The disadvantages of PAUT are as follows. Price. Equipment costs are still relatively high in comparison to conventional UT, but prices will inevitably drop with an increase in demand and growth between suppliers. Calibration complexity. A very in-depth calibration process involves adjustments of velocity, wedge delay, and sensitivity, which all have to be calibrated separately, plus time-corrected gain, TCG, to be conducted on holes at various depths. Transducer manipulation. Little to no probe manipulation during data acquisition is possible, which can often assist in real-time discontinuity identification in conventional UT. Geometry required. Details of the weld and parent metal configuration is required prior to creating a scan plan, which must happen preceding calibration, which must take place before any data acquisition. Lastly, lack of Australian standards. Problems arise when scanning fillet welds with conventional ultrasonics or phased array ultrasonics due to the lack of Australian standards available. At the current time, there is no Australian standard that gives guidance on the testing requirements or acceptance criteria. Australian Standard AS 2207 is the standard used for ultrasonic testing of fusion welded joints, which can be used as a guide when conducting PAUT, but doesn't actually mention phased array at all. The problem with acceptance criteria begins with AS 1554.1, which is very common in NDT. It covers the structural steel welding, Part 1. Table 6.2.1 offers permissible imperfections determined by ultrasonic examination, but defines lack of penetration as a defect. By its very nature, a partial penetration fillet weld does not comply to this standard. This lack of guidance was the driving factor to conduct my project. Experimenting on fillet welds with known subsurface discontinuities proved to be successful with phased array. PAUT clearly has benefits in the quality assurance fields, and while the holes in Australian standards exist, internal procedures will be the only way to perform inspections Australian standards.